Okay, now we are going to start a new module on SQL programming. This is one of the most important modules in this whole course because SQL is something that you are going to use for many years even after you graduate, right? So you should have a very good grasp on SQL syntax and the concepts pertaining to how to write an SQL query and all that, right? So pay specific attention to this module, and we are going to give you some sample practice lab sessions and also some sample data sets so that you can have a good hands-on experience with SQL. And remember that when it comes to SQL programming, the lecture and all this textbook knowledge will only take you so far. You need to get your hands dirty by working with an actual SQL installation. That's why I keep repeating this, that have an Postgres installation in your computer to get it going. Okay, so let's start. Yeah, so this is what is called as a table or a relation. I think I already covered this when I was talking about relational algebra, right? So you have a table like this, multiple rows, right? And this table corresponds to an schema, right? And each tuple in this table uh, comprises of some attributes. Like for example, I think this is the faculty table, and each tuple in this table contains a value for the ID, name, department name, salary. Some columns can be null here depending on what kind of constraints you put in that relation and all that. Right? We'll see more of this. And just a reminder that the order of tuples which you see in a table, it's totally irrelevant, right? So we will always go with a bag model, right? And if you put something like a primary key and all that, this bag essentially becomes a set also. But we'll see more of that as we go further. Okay. Next, the concept of keys. I remember we covered briefly about this concept of keys when I was talking about relational algebra, but here we have more details. So just to give you a quick review, any set of attributes of a relation R is called as a super key if those set of attributes can uniquely identify every tuple in that relation R. Right. So, for example, roll number and student name, that is a valid super key for a student relation. Right. Now, when a super key is minimal in size, so that means there are no superfluous attributes in that key, then that becomes an candidate key, right? So a super key is called as a candidate key if k is that particular super key is minimal in size. And by minimal, I mean that if you have an given set, you will call it as a minimal set if by taking out any attributes from that set, that set loses its property of being a super key, then we call that set as an minimal in size. Okay. Okay. So next important concept is the concept of foreign key constraint, right? So let's take an example. Let's say you have the instructor relation, and in that instructor relation you have details like instructor name, his ID, which department he is working on, what is his home address, salary, and so forth, right? And let there be another table where for each instructor you store the what courses he or she has taught, right? Now the let's say that in that teachers relation, if you want to have the all the details also, then it's redundant amount of data for because an instructor may be teaching multiple courses across the semesters, right? And then if you repeat all the instructor information in all the tuples of the teachers relation, then it's a space wastage, right? So in that case, what we do is that we just keep the instructor ID along with all the courses that he or she has taught, and the details of the instructor are in the instructor relation. right? So now if you have to connect these two tables via join operation, we use something like the instructor ID, right? So instructor ID of the teacher's relation will be used to join with the instructor relation, right? So in order to maintain sanity, SQL programming and all that, we use this concept of foreign key constraint. So what we say is that when defining the table of the teacher's relation, we'll say that the instructor ID of the teacher's relation is a foreign key, and it refers to the uh, it refers to an instructor tuple in the instructor relation, right? So this is the concept of foreign key constraint. And of course, there are more things which are required here. So for example, in SQL, at least in Postgres, I know that uh, in foreign key constraint, the attribute to which you are referring to should always be a primary key and all that. Sometimes these kind of constraints are there. Okay. If not a primary key, then it can also be you have to put something like a unique key constraint and all that. We'll see more examples. Okay. So let us go down into the SQL part. Okay, so SQL, broadly speaking, there are two things. So one is something called as the data definition language in SQL, and the other one is called as data manipulation language, right? So data definition language part of this SQL, it contains all the commands for creating a relation, assigning things like what is the domain of the attributes, any integrity constraints that you want to put, and other details like if you want to put an index and all that. So this is all the data definition language. And in the data manipulation language, you have all the select queries. Okay, so we'll first quickly cover the data definition language, and then go for the data manipulation language. So data manipulation language, the select from where kind of queries, that they form the major portion of the SQL, right? Nevertheless, data definition language is also very important. We should cover that because these help you to create the data. So we'll first start with the data definition language. Just a slide, containing the different data types which are available in SQL. Uh, the standard ones are integer, small integer, right? And if you have a numeric value with with a fixed precision and all that, you can have this data type of uh, you know numeric p comma d. You have double values. So this is in strings. You have two things. One is char and the other one is varchar, right? So varchar means that character string of variable length, but a maximum length of n. So that is called as varchar. So char n means that the character, the string should be a character, should be an array of character or something like that. The string should be of length n exactly. If the given string has less than n characters, then null values are padded and all that. These are widely used. Mostly varchar is used because it's little bit more space efficient and all that. Right? And of course, by no means this is an exhaustive list. So I would like you to go through the book, this matter, the Koth textbook, the SQL part, it's very comprehensive, very thoroughly written. They have a very long list of the attributes. So I have picked the typical ones that you would mostly be using. Okay. Okay. So let's go forward. Yeah. Create table command. So create table command is used for creating a relation, right? So the syntax goes something like this. So create table followed by the name of the table. Remember that this name of the table, uh, this is in whether you give it in caps or not, SQL is all lowercase, or best way to say is that it's case in case insensitive until unless you specifically give cases and all that. By default, it is all case insensitive. Okay, so you can put everything in small also, and even if you put it in caps, it will convert everything to small. Right? So create table R, and then open bracket. Then you have a list of attributes. So you have n attributes here, A1, A2, all the way up to AN, and for each attribute you define its data type. So data type is one of these things, right? And followed by that, this is important. You should try to remember that. So after this list of attributes, you have a list of constraints, integrity constraints on this table, and this constraints, it's a long list actually. Okay, so you have integrity constraints like primary key. You have something called as an unique key constraint, right? So unique key, by default, when you put a column as primary key constraint, you make sure that whatever data which comes into the table for that particular column, if it is defined as in primary key, it should be unique across all tuples, and you are not allowed to have any null values, right? So that is the definition of the primary key. And you can, if uh, primary key is not there, if the null values can happen, then you can put unique key constraint. Unique key allows null values. Okay. Okay. And there are other kinds of constraints and all that. As we go deeper, we will see. Okay, so this slide actually tells, it's a description of the data schema that we are going to use for this entire module. So this schema is an academic management system in a typical university. Let me just take 5 minutes to cover this schema, and we'll be coming back to this again and again throughout this model, because I'll be using this particular schema for all my SQL queries in this module. So largely you have main concepts like student, you have student name, ID, and all that. You have an instructor name, and all that. You have this department. This department attribute over here refers to this department relation, and students typically take courses, right? So now course is slightly non-intuitive. It's defined in a non-intuitive way here. Okay, so what goes here is okay. So here a course, when it is offered as couple of sections. You might remember in your first year, when you were taking those, technology museum labs and all that, the course was one course, but it had several sections, right? And a student was registered into an section. Okay, so that concept of section is there, and the section is defined by course ID, section ID, and with semester year. So this uniquely identifies a section across different offerings of, let's say, technology museum all across the years, right? And a student registers into a section, and similarly instructor teaches a particular section, because even in those technology museum, the class had maybe few hundred students, but each section had only maybe 60 students or so, and you would have an instructor for each section. Okay, so this concept of sections is incorporated in this particular schema, right? Student takes a section, an instructor teaches a section, right? So if a student is registered in a section, and tuple appears in this takes relation. So in takes relation, these four, course ID, section ID, semester year, it uniquely identifies a section, and then this is the student ID which is referring here, and then what grade did he get. Okay, so you might notice here that why am I saying that four attributes are uniquely identified. Remember that when we defined a key, I always defined it as an set of attributes. So here my candidate key of the section relation is these, the set contains of these four attributes: course ID, section ID, semester, and year, right? So this is my candidate key, right? And we can have multiple candidate keys in any table, and one of the candidate keys is defined as an primary key in the actual create table command. Okay, so let's try to see how to write create table for this particular schema diagram. Okay, let's see here. So first is the instructor table. Okay. Okay, so let's see this. So this is an simpler case, right? So create table, in name of the relation, ID. Let's say that it's character, name of the instructor. I'm putting it as varchar, department name varchar, salary, which is numeric. Okay. Now remember that instructor, you had some foreign keys. Department name in the instructor relation was referring to the a tuple in the department relation, right? So you need to put that in. So how do you put it in? You put the integrity constraints after the create table. Oh, in sorry, not after, in the create table command. Right? So now when you put that, uh, so you have something like this. So create table, instructor, ID, name. So this remains the same. Salary remains the same, comma. And now I have started putting the constraints, integrity constraints. I say that primary key is ID. So that means in all the tuples of this relation, this ID should not be null and should be unique across all of them, right? So that is what it means by putting an attribute as primary key. Now, once a table like this is defined and you try to insert a tuple where the ID is, it's repeated or it is null, the SQL prompt will throw an error saying that, primary key constraint is violated and all that, right? So it maintains the sanity. So this is the primary key constraint. Again, you have, as I said, you have something called as not null constraint. That means, it may not be null. Or you can have unique key constraint. That means that, those attributes must be unique with an exception of null values, right? The list is quite long. Okay, and but last but not the least, I want to cover this foreign key constraint. So I said that in this particular schema, the department name is an foreign key referring to a tuple in the department relation. How do I write that? So I say that I write this foreign key department name, which is this department. I'll say that, and it references department table. And if you are working in PostGRE SQL, then you have to even write the column name over there, right? So if in the department relation, if the name of the department is something like this, right? So then you have to write that column name in the department relation also. If you are working with Postgres, this is how it has to work, right? And as I said before, this is called as the referencing relation, this instructor, and then this is the referenced relation department. And this column which we are referring to must be an primary key, or in some version at least it should be an unique key constraint. But these things have, you need to check the actual vendor. But for all practical purposes, you this foreign key, you have to make it as an this part has to be a primary key of the department relation, right? And this actually helps you. Now what happens is that if department name is a foreign key which is referring to the department name of the department table, so let's say that I had a CSE, I had an instructor whose department name was CSE, and it was referring to the CSE tuple of the department relation, and we had put this foreign key constraint. Now, in a situation like this, if somebody goes and tries to delete the CSC tuple from the department relation, it throws an error, that foreign key constraint, right? So you are not allowed to delete any tuple from the department relation if there are tuples in the other relations which are pointing here, right? So this is the beauty of foreign key constraint. It ensures that you don't end up with any dangling pointers, right? But if you have to delete, there are further constraints that you can put. You can have a constraint called as on delete cascade. So that means if you delete the department tuple, CSE department tuple here, then all the CSE instructors will also get deleted, right? So those kind of things are there, and depending on your requirement, you can put it in. Okay, now let me just write it like this. Okay, so now, okay, let's go to next slide. Okay, so in this slide, I have just more examples from the student and the takes, right? So student, again, you see ID, name, department name, all is this written. I have put in a primary key. I have put in the department name as foreign key. And as I said before, this in post-GRE SQL, you have to write the column which is being referred also, right? And here, yeah, so this is an example of the takes relation. Remember takes relation, this one, right? A student is registering into a section by putting an tuple in the takes relation. Now, how does that work? So the usual, ID, course ID, section ID, everything is written. Primary key is a combination of these attributes, right? And then I have put all the foreign key references, right? So over here, all these four together became the primary key, and this portion, course ID, section ID, semester and year, they were referring to section table, where those set of four attributes is the primary key, and ID was reference referring to the student table. Right? So those things are written as foreign key constraints over here, right? So here, as I mentioned before, you have to write the ID of the student table, which is referring to. And similarly, in the references section, you have to write all the four relevant attributes of the section table to which these will be referring to. Okay. So yeah. Okay. So next set of queries, next set of commands in data definition language, you have commands for insert, delete, drop, and alter. So insert helps you insert a tuple into a relation. So I'll write something like this: insert into relation name, values. I'll give values for each of the columns, right? And delete, we'll try to remove tuples from a student relation. Let's say that, I'll say delete from student, and then there will be a where clause. I think I have more examples on this later. If you want to delete a table, you have to say drop table. If you want to alter the schema of a table, you have a command called as alter table, table name, add an attribute, drop an attribute, add a constraint, drop a constraint, right? So you have commands for all of that. It's, I'm not going to go into a whole lot of details of these. I think the textbook does a fair job, and beyond that, if I start teaching all the ways in which you can insert into a relation, you'll just get bored. I think they are pretty straightforward. You can just read it from the textbook. Okay, now the data manipulation language. Okay, data manipulation language is basically select from where kind of queries, right? And these are is a big, substantial amount of things that you can do here, right? So the basic structure of these queries, you have select clause followed by a list of attributes, from followed by a list of relations, and then the where clause, right? So this is the typical structure. So just be a little bit careful here. So I say select followed by attributes, but if you try to connect back to your relational algebra, this select is corresponding to your projection attribute, right? And the actual select clause, the sigma and the condition that you used to write, that clause is this where clause, right? And this from is the the relations, if you create Cartesian products and everything over here, right? So this select is actually the corresponds to your project operator back in your relational algebra, right? So we'll slowly start to develop this concepts. Let's try to see here. So as I said before, select clause just lists the set of attributes which you are interested. So for example, select name from instructor. So what it will do is that it will take the instructor relation and it will just project it on the name uh, column of the instructor relation, right? And as I said before, SQL is a bag language. If you have duplicates, it will show the duplicates as it is, right? And if you want to remove duplicates, you have some other commands that you put here, right? We will see them shortly. Okay. Yeah. So now how to remove duplicates, right? So if I do something like this, select, forget about this distinct clause. If I had just written select department name from instructor, right? So if I had written like this, then in the instructor relation, department name, there would be several copies of the department name in the instructor relation, right? So I put in this keyword of distinct. So if I put the distinct, then only first it will do the projection, and in that projection you will have multiple copies of the department name. CSE will be repeated several times, once for each instructor of the CSE department. And if you put in this distinct keyword, then it will take out only the distinct department names that are seen in the instructor relation, right? But conceptually speaking, the way to think about it is that you loop over all the tuples of the instructor, you take the department column attribute, and store that in a temporary relation, and then distinct operator is put on top of it to give you all the distinct department name. That's the way to think it conceptually, right? So this select all keyword, it's given in the textbook, but I think this is really not that needed. By default, it does it throws out everything with the duplicates. Okay, so I would not pay a whole lot of attention to this, because these things, they matter. You know Different software vendors implement differently. By default, select will give you duplicates, and if you want distinct, you use the distinct keyword. That's the summary statement that I want you to take. Okay, now couple more details here. So if you have something like this, if you want to retrieve all the attributes of an relation, then you write select star. So that means there is no projection going on. Uh, from each tuple of the instructor relation, you throw out all the columns, right? Okay, and then these are some little things I think you can take care of. For example, you can rename a column by using as and all that. That's okay. Okay, and you can do a little bit arithmetic on the column value. So for example, over here, uh, what we are doing is I'm selecting ID, name, all from the instructor relation, and whatever salary is coming, I'm dividing it by 12 to get a monthly salary, right? And I'm also renaming it as monthly salary, right? So something like this can be done. So salary attribute in the instructor relation, that might be yearly salary. But if you want a monthly salary, you can quickly do some little arithmetic over here and rename the column in the final output, right? So these little things, they are allowed. They are handy. Okay. Of course, by no means what I have covered is an exhaustive list of things that can be done. I'm telling you the most most widely used things in the select clause. Okay, then the where clause. Okay, so where clause is used to define the Boolean conditions which you saw in your select relational algebra operator. So, for example, if you want to retrieve all the instructors whose department is computer science, what you do? No, so the way to always write a query is that things to be written after select should be decided at the end. So first you have to see what relation you are interested in. So the data that I want is sitting in the instructor table. So when I say from instructor, that means I am going to loop over all the tuples of the instructor relation. And for each tuple of the instructor relation, I am going to pass it through the select operator. Remember the select operator in relational algebra? That select operator is this where clause. Right? So for each tuple of the instructor relation goes through a select operator, and in that select operator, I check that for that tuple, the department is computer science or not. If the department is computer science, the tuple passes, and for that tuple, I retrieve the column name. So that is the way to conceptually think about an select from where query, right? Always whatever is written after the select command, you see it last. The first thing that you should see is what is your table that you are reading from. I'm in this, for example, in this particular query, I want to have the instructors from CS department with salary greater than 80,000, right? So all the information that you need is in the instructor table. So after from, I'm going to write the instructor table. Now, if the information required is in more than one table, you have to do and join, or conceptually a Cartesian product. So I would have written instructor comma department name. We will get there, right? So first is that you create your you get your tables in place, the tables that you are requiring, right? So for this particular query, I require the instructor table, right? And now you loop through every tuple of that table, or if it is more than one table here, then you conceptually create the Cartesian product, and then you loop over all the tuples of that Cartesian product, right? So here you just had one table, so you loop over all the tuples of the instructor table, right? And for each tuple, you pass it through the following where clause, or pass it through the following select operation as per the relational algebra terminology, right? So for each tuple, I check whether department name is computer science or not, and what is the salary. And if the salary is greater than 80,000, the tuple passes. And for all the tuples which pass through your condition in the where clause, you finally come back and see what projection you are doing, right? So first, table. Second, the where clause. Third, the select. That is the way to read an SQL query, or even formulate an SQL query. That's the way to do it. Then you will not make conceptual mistakes, right? Okay, so don't worry, we have some live sessions that we are planning. We will give you a sample data set, we'll conduct some live sessions. In those live sessions, the TAs will actually try to create some simple queries, and they will explain you how to write those. Some more features of the where clause. So if you have something like this, that you want instructors whose salary is between 90,000 and 1 lakh, so you can write like where salary between this number and this number. These are little things. And you can also create in the where clauses, instead of an individual attribute comparison, you can also create some kind of a tuple comparison. So over here, what it is doing is that, so you have instructor and teachers. So always, as I say, start from the from clause. What is your grand data set that you are going to read? My grand data set over here is the space of Cartesian product between my instructor relation and the teacher's relation. So I created this Cartesian product conceptually, and then I'm going to loop over every tuple of that Cartesian product, and for every tuple, I'm going to check if the instructor ID and department name, if they match teacher's ID and biology and all that, right? So, right, so just to show you that, you can do tuple comparison. Of course, there is more than one way of writing an SQL query. Just to illustrate some things, we'll see. Okay, cool. And then finally, the tuples which pass through, you do the projection over here. Okay, so I actually leave this as an exercise to you to actually, figure out what is this query doing. So you should be able to do both. Given an English question, you should be able to write an SQL query, and given an SQL query, you should also figure out what it is doing in English. Okay. From clause. Okay, I think I have already covered this informally before. So from clause, as I said, it lists the tables from which you're interested in taking the data. If it is just one tuple, one table, you're going to just conceptually loop over all the tuples of that table. If your data is in across multiple tables, you create this conceptual space of Cartesian product, select star from instructor comma teacher. So this creates a Cartesian product between the instructor and the teachers. You remember the cross product operator in relational algebra? This is equivalent to that. So every tuple from the instructor table is matched with every tuple from the teachers, right? So from that grand space, you do some selection. And I would like to stress here is that, when we are dealing with SQL and all that, it is still at logical level of the database. So that means we are not going to worry about the performance. We are going to get the concept right, and then the query optimizer will figure out what is the right way of doing the join operation and all that. Okay. So just to give you an example, let's pick one table. Right? Okay, so let me take this. Right. So let's say that you have a query, and you are required to find the names of all the instructors who have taught some course and the course ID which they taught. Right. So forget about the select. Always start from the where. Like I think I have my schema over here. Okay, so yeah, so we want names of the instructors and who have taught some course, right? So first thing that we ask is that where does this information lie? Is it in one table or is it in more than one table? So you go back to your schema, right? So instructor name will obviously come from the instructor table. Now whether he or she has taught any course will come from the teachers table, because whenever an instructor offers a course, and tuple gets inserted into the teachers table, right? So the information that you need for your query will obviously come from a join between the instructor and the teachers table, right? So that's the way to figure out, right? So once you know that, the first thing that you're going to write is from teachers comma instructor. We are not even talking about this select. We'll always start from the from clause writing of the SQL code, right? Now we know that you have to join teachers and instructor. So we'll write from teachers comma instructor. Conceptually, a Cartesian product is now created between teachers relation and instructor relation, right? And now from that Cartesian product, you have to select out the tuples which correspond to the join between the instructor and the teachers table, right? So now, how do we do that? We write an select operator, which is the where clause. Instructor.id is equal to teachers.id. Remember that whenever we were joining, we always said that A join B is equal to sigma followed by the join condition and A cross product B, right? So conceptually, this is what it is doing. It is first conceptually creating that Cartesian product and then filtering out the joint tuples. Remember that in the actual implementation at the physical layer, this is not how it might execute. But for conceptual understanding, this is the best way of understanding. That is why we write it like this, right? So that's the, as I keep on saying, that's the beauty of a database system. When you are writing a business query, you just have to worry about getting it conceptually correct. The actual physical efficiency and all that part, you just leave it to the internals of the database, right? So this part is actually performing an join between the teachers and the instructor relation, right? There are other ways. SQL does have the keyword natural join also, so you can have natural join, or I think there is also a keyword join in SQL, right? So there are more than one ways. Okay, so after you have joined the teachers and the instructor relation, now what will happen is that only those tuples from the instructor will get joined to the teachers who have actually taught a course, right? Otherwise they would not even join, right? So that's the whole story. If there is an instructor who never taught a course, who never offered a course, then that ID will not show up here, right? So in the join result, you will have details of only those instructor who taught and who offered at least one course. And from this set of tuples, what you have to do, you finally write the select command. In the select command, you said that I wanted names of the instructor and the course. So for that, what I write, select. Okay, I wrote here ID. Sorry, I should have written here name. Okay, I'm giving the instructor name and the course ID which he taught. Now an instructor might have taught this course multiple times over the years. If you put a distinct clause over here, then it returns unique values of these pairs. So if an instructor teaches the same course multiple times, for each offering he will have a tuple here, because he might be offering that course multiple times across years. Right? But you want to retrieve that information only once, so you put the distinct. So it will return the unique value for these pairs, right? It filters out the duplicates. So the second one is also pretty straightforward. It's the same story. Find names of instructors who taught at least one course, but we want this information only for the instructors who belong to the arts department. Now, how do I do that? Again, first always start from the from clause. The information that you need, that the instructors have to be in the art department and they should have taught one course. Now how do we do that? You always go back to schema. Okay, the department name is there in the instructor relation. That means if you are interested only in the instructors of the arts department, you can get it from here. Now, this instructor should have taught at least one course. So whenever an instructor teaches a course, he gets a tuple into this teachers relation. So all the information that you need is in these two tables. What you do, so you create an join, right? So that join part is that from teachers comma instructor and where clause, right? So this highlighted portion is creating the join, right? So just this highlighted portion is going to give you all the instructors who have taught at least one course. Now there is an extra filtering condition. It says that instead of in addition of teaching one course, he or she must be from the arts department. Now how do you put that? You put one more where condition, and department name is equal to R, right? Now what it is doing is that it is now filtering out the throwing out the tuples which belong to instructors who have taught a course but they are not from the arts department, right? So the where clause allows you to keep putting and further conditions like this, right? So I hope you are understanding the conceptual part. You first create a conceptual cross product and then you write a where clause which will give the tuples that you are interested in. Then that where clause, you think it modularly. First you think what should be my condition of join. After that join condition, what other constraints are there? So for example, I say that the instructor must be from art department and he should have a salary greater than 10 lakhs. So you write here another and salary greater than 10 lakhs, and we are able to do all of this because all this information is sitting in my Cartesian product between teachers and instructor. So that's why I always say that first get your grand data set, which is Cartesian product or whatever. First get that concept down. So after doing that, you start throwing in the select operators or select conditions or Boolean conditions. Once you do all of this, finally you go back and write the select clause. The select clause being, I retrieve the only the name and the course ID, the project operator, and we are writing a distinct just to remove duplicates. Okay. Okay, so there's a small concept of renaming a relation, and we do something like this. So let's say we are doing an join operator of we doing a self join, instructor versus instructor, right? So here what we are doing is that we are writing instructor as T and instructor as S. You remember in relational algebra I was saying that you take two copies of the table. This is that two copies of the table example. So I have created a copy T of the instructor relation, and then I have created another copy S of the instructor relation, and then I am creating a cross product between them. Okay, so this as is used for sort of creating a copy of the relation. Sometimes as may not be written, you just write like this instructor T, that means it is assumed that this is a copy of this instructor relation.